Welcome to G Fun Facts Online. For years, the story of artificial intelligence has been simple: bigger is better. We've heard about massive AI models with trillions of parameters, trained on the entire internet, capable of incredible feats. But this race for size comes at a cost: astronomical computational power, huge energy bills, and barriers that keep this tech in the hands of only a few. But what if the next big thing in AI is actually small? A quiet revolution is happening, and it's all about the incredible shrinking AI. Today, we're diving into the world of small language models, or SLMs, and discovering how these compact, nimble powerhouses are proving that when it comes to AI, size isn't everything. So what exactly is a small language model? Think of it this way. A giant large language model, an LLM, is like a massive, all-encompassing encyclopedia. It knows a little bit about everything. An SLM, on the other hand, is like a concise, expertly written field guide. It's specialized, detailed, and incredibly useful for a specific purpose. While LLMs might have hundreds of billions of parameters, SLMs range from just a few million to a few billion. This isn't just about shrinking the size. It's a completely different design philosophy. It's about prioritizing efficiency and nailing specific tasks. This efficiency brings huge advantages. SLMs are cheaper to train and run, which means smaller businesses, startups, and even individual developers can now get in on the AI action. More importantly, their small size means they can live directly on your devices: your phone, your laptop, your car, even your smartwatch. This is called on-device processing. It makes AI faster by cutting out the trip to a cloud server, and it makes it more private, because your personal data never has to leave your device. Of course, there are trade-offs. An SLM trained to be a legal assistant won't be great at writing poetry. They don't have the same vast general knowledge as the biggest models. But for a growing number of tasks, the small is beautiful era of AI is proving to be a powerful, practical solution. Creating these powerful little models is a fascinating blend of science and art. It's not just about using fewer building blocks, it's about building smarter. AI researchers use several clever techniques to miniaturize AI. One of the most important is called knowledge distillation. Imagine a wise, experienced professor. That's our large teacher model. Now imagine a bright, eager student. That's our small student model. The student doesn't learn from reading every book in the library. Instead, it learns by listening to the professor. It mimics not just the final answers, but the professor's reasoning, the nuances and connections between ideas. By learning this distilled wisdom, a student model like Distilbert can be 40% smaller than its teacher, Bert, but keep 97% of its language skills. Another technique is pruning. Just like a gardener snips away unnecessary branches to help a plant thrive, AI engineers prune neural networks. They systematically remove the least important connections, the fat, from a large model to make it smaller and faster without hurting performance. Then there's quantization. This is like teaching the model to speak in a simpler language. Normally, AI models store information using highly precise 32-bit numbers. Quantization reduces this to less precise formats, like 8-bit integers. This alone can make a model 4 times smaller and significantly faster to run, all while consuming less energy. Finally, there's a set of techniques called parameter efficient fine-tuning, or PEFT. This is about efficiently adapting a model to a new task. Instead of retraining the whole model, you freeze most of it and only tweak a tiny fraction of its parameters. It's like adding a small, specialized tool to a multi-tool instead of building a whole new workshop. Techniques like LoRa and adapters allow developers to create highly customized models with minimal cost and effort. So we have these small, efficient models. Where are they actually showing up? The answer is everywhere. The biggest impact is in on-device and edge intelligence. By running AI directly on your device, SLMs enhance privacy, reduce lag, and even work completely offline. Think about your smartphone. The smart replies in your messaging apps, the incredibly fast offline translation, the predictive text on your keyboard that seems to read your mind, those are increasingly powered by SLMs. Google's Gemini Nano on Pixel phones and Apple's new Apple Intelligence are built on this very idea, bringing powerful AI features to your pocket without constantly sending your data to the cloud. In the business world, companies are using SLMs to build hyper-personalized customer service chatbots. These bots are trained on a company's own manuals and data, so they can give you accurate, relevant answers instantly, freeing up human agents for more complex problems. In law and finance, SLMs are saving thousands of hours by analyzing and summarizing dense contracts and reports. Healthcare is another massive frontier. SLMs can power secure, private patient assistance on your phone, help doctors summarize patient notes to reduce burnout, and even analyze data from wearables to provide early warnings for health issues, all while keeping sensitive patient data safely on the device. From fraud detection in banking to predictive maintenance in factories and natural language controls in your car, the applications are exploding. SLMs are making AI more accessible, responsive, and seamlessly integrated into our daily lives. This revolution is being led by a mix of tech titans and agile newcomers. Microsoft has been a huge pioneer with its Phi family of models, which have shown that smaller models trained on extremely high-quality data can punch way above their weight. Google has its open-source Gemma models and the on-device Gemini Nano. Meta's open-source Llama 3 models, especially the 8 billion parameter version, have become a favorite for developers. And Apple is going all in on on-device AI with its suite of SLMs powering Apple Intelligence. But it's not just the giants. The French startup Mistral AI has taken the world by storm with its incredibly efficient Mistral 7B model, which rivals models many times its size. And none of this would be possible without platforms like Hugging Face, which has become the central hub for the open-source community, allowing developers everywhere to share, collaborate on, and build with these small but mighty models. So what does the incredible shrinking future of AI look like? One of the most exciting concepts is agentic AI. Imagine not one AI, but a team of specialized SLMs working together like a symphony. An orchestrator agent could take a complex goal, like plan my trip to Japan, and delegate tasks to different specialist SLMs, one for flights, one for hotels, one for restaurant reviews. This modular approach is far more efficient and powerful than relying on one giant model. NVIDIA has even said that small language models are the future of agentic AI. The next step is also multimodality. SLMs that can not only understand text, but also see images and hear audio. Models like Microsoft's Phi 3 Vision can already look at a picture and answer questions about it. Soon, this will enable a whole new generation of intuitive, helpful AI. But the rise of SLMs doesn't mean the end of large models. The future is collaborative. SLMs will be the workhorses, handling most tasks on our local devices quickly and privately. When a problem is too complex, the task can be seamlessly handed off to a powerful LLM in the cloud. It's the best of both worlds. Of course, challenges remain. We need to improve their reasoning, ensure they are trained on unbiased data, and prevent them from making up facts. But the trajectory is clear. The era of the incredible shrinking AI is here. It's democratizing access to technology and weaving intelligence into the fabric of our world. The future of AI may be small, but its impact will be anything but. Thanks for listening to G Fun Facts Online.